Hi everyone, we will solve GATE 2016 Aerospace Engineering question number 5. Which of the following statement is not true across a oblique soft wave? Option A, static temperature increase, total temperature remain constant. Option B, static pressure increase, static temperature increase. Option C, static temperature increases, total pressure decreases. Option D, static pressure increases, total temperature decreases. So this problem is from oblique soft wave. To know more about oblique soft wave, you can refer to NPTEL lecture by Professor B. Babu from Department of Mechanical Engineering, IIT Madras. So first we will see about oblique soft wave. So when supersonic flow passes through a symmetrical page or a concave corner, then a soft wave is generated, which is the oblique soft wave. So in oblique soft wave, we assume that flow is steady, flow is 2D, and flow is unviscid flow only upstream and downstream part of the flow. In between this oblique shock, this flow is inviscid, is highly viscous. So across the oblique shock wave, flow is not inviscid. Flow is also adiabatic flow, and there is no external shaft work done. And the gas is calorically perfect gas, and there is no body force. So here deflection angle is theta and shock angle is beta. So governing equation can be derived from this using the continuity and momentum equation. So there are some physical trends which can be found through governing oblique shock relation, which is this M1. M1 properties are for upstream and 2 is for downstream. So this M1 is always greater than 1 for oblique shock. Temperature increases across the shock. So temperature T2 is greater than T1. Mach number decreases. M1 is greater than M2. Total temperature is constant because flow is adiabatic. So T01 equal to T02. Total pressure decreases because this oblique shock is a discontinuity, so there will be entropy, increase in entropy, and increase in entropy associated with the pressure drop, because P02 upon P01 equal to e to the power minus delta S upon R. If delta S is greater than 0, hence this P02 will be less than P01. Pressure and density both increases across the shock. So now we will come back to our problem. So what we have seen, that temperature increases, pressure increases, density increases, total temperature remains constant, and total pressure decreases. So first option, static temperature increases, which is true, and total temperature remains constant, which is also true. So this option is true. Second option is static pressure increases, which is true, and static temperature increases, which is also true. So this option is also true. Third option is static temperature increases and total pressure decreases. Static temperature increases, which is true, and total pressure decreases. Total pressure also decreases, which is also true. Static pressure increases, which is true, and total temperature decreases. This is wrong because total temperature remains constant. So this option is false. So only option which is not true is option D. So this is the answer. Thank you.